So when people think about criminal hackers and all the sort of black hat hackers out there, often find a clever way in that's only discovered by experts, decades later. They make tons of money, and just generally are really cool. Well, the problem is, in reality, most of them aren't. Most of them just go on forums and download scripts, or on GitHub, download scripts from there. They spam vast numbers of servers, and no, the connection seems to have died. Okay. Well, I'm going to keep talking. It's loads of it. They spam through vast numbers of servers, trying to find any of them that their script will work on. They Google and YouTube various tutorials to try and get in. And usually they make basically no money, and get pretty bored of it very quickly. The more advanced criminal hackers probably won't target you, because there's nothing really on your system to go for, is there? They can waste their time on some small student's computer, or they can use a similar amount of time trying to break into a large company or something like that. So generally, you don't have too much to fear from serious hardcore criminals on your computer, in the same way that you don't have much to fear from the mafia breaking into your house. So most of these script kiddies use freely downloadable tools. So these things are denial of service scripts, vulnerability scanners, Metasploit, and credential spraying. So I'll walk through each of those in turn. Let's see. So for denial of service, there are three main types of denial of service. First one is distributed denial of service, DDoS. It's a pretty low skill attack. It's quite expensive to run. You need a lot of computers all spamming a request at a remote server, in the idea that you just flood its bandwidth or CPU capabilities and turn it off. Often, to try and get yourself a leg up over, you can, instead of, just spamming directly, you can bounce off. Well, you place it. You can spam them directly. Instead of spamming them directly, you spam them through another server. So a classic technique is to spoof your IP address, pretend you're coming from a different IP address, and send a vast number of requests to a DNS server. The DNS server will respond with a payload that's much bigger than the request you send. So, you request myevilsite.com, and get it so that the DNS record for myevilsite.com is, a couple of kilobytes big. And then you can amplify what's, a couple of 100 bytes into thousands of bytes, making your actual final amount hitting your target massively increased. However, if DNS servers detect you're doing this, they'll just block you, at which point your entire attack just stops. Flooding vast numbers of packets through the internet actually slows down the backbone. There are various instances, especially in the early internet, of large viruses and DDoS attacks actually saturating the internet backbone between countries, taking out the lines communicating between, UK and America. As such, because, DDoS attacks do not just attack your target, but the things you're bouncing it off, the networks you're going through, they are incredibly illegal. They will never be in any pen test you're going to do. Maybe as part of a recovery, but you will never be performing a DDoS legally, because it can't be done. In the same way that you can't go down a road which is full of other cars at 200 miles an hour and expect not to be breaking the law. So to block against DDoSes, there's not a vast amount you can do. The general things just fall under getting someone else to handle the vast amount of traffic for you. So using a content distribution network, or a VPN, like a VPS or something like that, will allow you to balance your load between different servers. And if you have enough servers and you've got caching for static content, the actual amount of time you have to spend dealing with all the spam requests decreases drastically. If you're a large data center, you can actually mess with the local internet packet routing using something called BGP, a border gateway protocol, and block entire regions from the packets even reaching your system, so you don't even have to filter them out. It's done at the internet level. On a sort of smaller scale, if you can't afford to have giant content distribution networks, or you don't have access to an edge router, you can spin up more servers on a VPS provider to handle the spike in traffic. Oh yeah, it might be worth pointing out, Cloudflare for free offers a decent DDoS protection service that will get people to have to run some JavaScript on any browser trying to access your site before it forwards it through to you. So static captures and proof of work pages can be used to slow down spam, so they have to fill in some puzzle before they actually get to your site. And of course, if you're a coward, you can just turn off your site and wait for them to go away. Because if you're DDoSing someone, it massively decreases your bandwidth, because you're using all of it to try and attack someone. Often, people get bored within a couple of hours, maybe a few days if they're particularly annoyed at something you've done. You've started murdering baby pandas on live TV. People don't like you. They DDoS you. These really don't go on for too long. So if you can't defend against it, you can often just wait it out. If you're a business, you'll lose the profits for that time, but it means you don't have to spend hours and hours fixing all of your servers who are hitting weird edge conditions because of the high load. Someone's just suggested redirecting your traffic to Mossad. That's an idea. I would suggest against abusing routing to do that. Partly because you'll actually have to handle all the traffic and then forward it onto Mossad. So what it will look like is you are DDoSing Mossad, which is not somewhere you'd particularly want to be, I can imagine. Anyway, so let's go on to the other one. So first of all, let's talk about CAPTCHA. You'll see many sites using it as some way of proving that someone is a human. This isn't true. You can actually solve these with machine learning. And if you can't be bothered, you can go on the internet, search you can search for CAPTCHA Solve API service, and you can post each CAPTCHA you get. You can take a screenshot or pass the link, and it will send it off to a horrifically underpaid worker in a third world country who will solve the CAPTCHA for you. You can get about 1,000 for £1. Obviously, this is questionably ethical. But if you're an attacker, you probably don't care about that. It's not outside the region of any, even poorly funded attacker. You can do a lot of damage with 1,000 bot accounts. So this only really can be used to slow down and increase the expenses of an attacker trying to get into your system. There exists an alternative scheme to CAPTCHA called proof of work, which some of you may have heard of, where the idea is to solve a difficult puzzle, usually something called a partial hash inversion, where the idea is you brute force random values until it hashes down to a value smaller than a certain number. So, you treat the result as a 256-bit number, you hash random data until you get below a target, send that number across, and the server can validate it really quickly, but it takes a long time to find it. These are, however, quite resource intensive. Instead of wasting a human's time, you're wasting their CPU time. And most modern browsers block it. I know Firefox has a thing to stop it, because basically this is actually the same system used by Bitcoin and Ethereum and all these other systems. And so it's very easy for it to be caught as a crypto miner, because effectively that's what you're doing, except without actually getting cryptocurrency out the other side. And a well-funded hacker can just buy ASICs or some specialized hardware to do these hashes very quickly. At which point it stops being, you are spending a disproportionate amount of time as a legitimate user when an attacker can solve it in thousands, sometimes even millions or billions of times faster than a normal user. Anyway, back onto the main topic. So the next type of DOS is what I call a heavy query DOS. So this requires a bit more thought and consideration than a DDoS. You're actually looking for things to take out with the website. It's cheaper because instead of trying to saturate their bandwidth or just directly saturate their CPU resources, you look for things that cause more load than it should be. So, for instance, find a page that's really slow to load. That often will be because there's a database query in the background, or because it has to think a lot before doing it. I've come across sites which have like a 30,000 database entries, and it loads all of them each time you load the page. So if someone just sat there requesting that page over and over again, you wouldn't need too much bandwidth to do that request, but the actual amount of resources being consumed by your target would be horrendously more. These sort of things generally aren't in scope. You might get it if you're on an internal pen test, or if you're just a developer. Frankly, this is less of a security vulnerability more than just bad code that slows down your system. So to fix it, you want to first of all try and optimize the code. If you have something that's slow, that's consuming a vast number of resources on your local machine, chances are you've written it badly, and you can fix it just through normal optimization techniques. Also, for difficult pages, instead of doing anything fancy like per user tracking, you can just say, only allow this page to be requested 5 times every second, which means that legitimate users who will need that page will have to wait in a queue, and it will slow down their experience, but it won't slow down your servers, and it won't slow down other uses of a legitimate user. You can also use, again, a capture or proof of work before performing the actual request. You can also just disable the page. If you're under attack, people are requesting the same page over and over again, and it's slowing down your site, you can just turn off that page. If it's non-critical functionality, which users don't generally use, which if it's past QA, it's probably not, you can just turn it off and most users won't be affected. And the final thing you can do, if you've got, again, large scale, or a good development team, you can split off the high levels of computation and database queries onto separate servers so that you don't actually need to bother dealing with it on your main server. So if a user requests this heavy site, it doesn't interfere with the user interacting with the website normally. So the final one is an exploit denial of service. So these require the most skill of the three. You're not spamming a website with just brute force. You're not just finding something that takes a while to load and then spamming that with brute force. You're finding something in the website that induces some unexpected behavior, be that a crash or an infinite loop or something of that form. Once you discover one of these things, it's usually very cheap to run. And due to the wonders of modern technology, high availability systems that are used to distribute load between servers will happily send your exploit to each server in the data center so you can crash them all at once. Often you find these by accident, so you load a page, the website crashes, you go whoops. That's generally why you should have logging for your websites and have report codes and stuff. Also happens when you mess up memory corruption. So if you're trying to, if someone's got a buffer they're reading too much into and you're trying to smash the stack, if you can't find a way of actually overwriting their return pointer and getting control of the program, you can easily crash it just by spamming invalid values. It tries to read those, it goes whoops, and then crashes. These sometimes are for like bug bounties, but quite rarely. Frankly, the only time you really want to say this is, you've got a binary exploitation you can't exploit. You still want some money from the bug bounty, so you can say it's a denial of service vulnerability. But with these things, you have to be incredibly careful, because if you actively go looking for ways to take out a server, that's quite dubious. Unless you've got like pre-written permission, and usually most bug bounties will have something saying DOS vulnerabilities do not count, which means that if you find one of these things, it's a question of whether you disclose it. And if you do find one of these things, you need to make sure not to call it any more than you absolutely have to, because it can be very expensive to go deal with crashed servers. Okay, sorry. Someone's just asked me to deal with questions in chat. So okay, yes. So with power systems, they often will have redundant power supplies, often generators. I know some data centers actually have their own generators separate from the grid. And I don't know. I mean, off the top of my head, you could try plugging alternate server rows into different power supplies, so there isn't just one cable to unplug. Um, is there a big kill switch? Maybe, probably for fire reasons. But I don't know. I'm not. I don't work in a giant data center. I think. Yeah, I know. Frankly, if you can think of an easy way to destroy something which is used by billions of people, chances are someone else has already thought about it. But servers do become do server like data centers do stop working. Like, it's not like this isn't unheard of, but I would say there isn't like a big cable you can just pull out of the wall and all the servers turn down. Partly because the big cable would have to be really thick and be very inefficient power-wise. Anyway, back on to the presentation. So how do you defend against denial of service attacks through actual exploits? Well, you patch the bug. I mean, it's not really anything else you can do. If someone is spamming you requests, again, you should have logging to check what people are spamming, and it's crashing something. You can go and just look at what site's causing it, maybe turn off the site page temporarily, or just quickly get a fix out. But you can't really do something. It's a vulnerability in your program. It's not something necessarily you can mitigate. You can mitigate the damage caused by it by, for instance, having a backup site. So if you notice that your website keeps going down, have a fallback website that works. I mean, for instance, for the Cybersock Discord bot, which is the most stable piece of code ever written by mankind, when it crashes, it automatically reverts to a previous known stable state, so that we can develop with it. If something goes wrong, the bot doesn't just die. And you can do a similar thing with websites. You can also just have, if you've got like a complex page that loads many things, you can just have a simple version of it that works even if the site has crashed. So, your Google, you've got a search engine, you want it to still work. We'll get rid of you can like temporarily disable advertising or something to see, and have like a very bare bones pure HTML page. Whether you want to do that is a different question. You can also separate out components of fault tolerance. So if you've got, it shouldn't be that a small part of your website crashes and then the whole thing goes down. If you have them so it's not tightly coupled, you can keep the system going so that even if a bit of it dies, the rest of the website's still usable. So, now let's go off denial scans. These are the bread and butter of Skiddies. These are scripts that look for common mistakes, so XSS, CSRF, SQL injection, things like that. Usually they're not brilliant, they catch the obvious stuff, but they'll miss things that are more subtle. So, for instance, a stored XSS that has to be, a stored XSS that has to have a certain number of conditions met. So you have to tick a couple of boxes to get it through. So they will spam you with bugs that don't exist or that no one cares about. So, for instance, for preferences cookies, it will spam you saying it's not HTTP only. It will go, this website could be embedded in an iframe, when that's its entire purpose. They can be rather annoying to use. There are a couple of examples on screen. I won't walk through them, except for maybe fuzzers. Fuzzers are a special type of vulnerability scanner. Oh, don't say it's buffering. Okay, give me a sec. If it's buffering, I will check if it's me. Oh, that might be me. Wait for my system to catch up. Okay, cool. So for fuzzers are a special type of vulnerability scan. So you've got, web scanners and port scanners and things like that. You've also got something that basically spams programs with interesting looking input. So a classic example is you've got something that parses URLs. So what you can do is start just spamming it with things that look like URLs but aren't, or long sequences of characters to try and cause a buffer overflow, or nulls to see if you can get past various buffer copies, things like that. Often these things basically just take wild shots in the dark, so they don't really work over networks too well. They might sometimes, but it's not really something you can worry about remotely. It's more for sort of local execution discovery, local vulnerability discovery of binary exploitation. These things can be in scope if you're contracted in. So lots of pen tests will involve just running like a bunch of scanners, waiting for the results to go back and then seeing what you get. It's good for recon. But if you're on a bug bounty, I actually haven't come across a single bug bounty that doesn't say vulnerability scanners are out of scope, because they will have run the vulnerability scanners on their thing. You run it, you get all the results, you're done. You don't really gain anything from running it again unless you update your code. So keep that in mind. They're useful for internal testing and for pen testing, but for bug bounties, you're not going to get anything. Because, I mean, even if it was in scope, someone else would have run the script and found it before you, probably. So, I have linked in the description a talk. Buzzers do work if things are programmed in Rust. I know that's a joke, but it's an important distinction to make. Not all vulnerabilities from manipulating data come from binary exploitation. And of course, if your Rust thing links to a vulnerable C library, then you're as vulnerable as the vulnerable C library. And since everything uses libc, you're limited by that. I'm not saying there's an exploit in libc. I don't know when the last one was, but it was a while ago. These things are very well audited. But and actually, lots of, the classic example is PHP. PHP is memory safe. There's no way of legitimately causing memory corruption in PHP, short of there being a bug in the actual language or you doing some spooky magic that you deserve to be hacked over. But PHP, of course, is the classic example of a language gone wrong, in that the string, just because all the functions are safe in that way, doesn't mean there aren't any vulnerabilities dependent on data. So, one definition you could give of hacking is messing with systems that conflate data and instructions. But, that's getting a bit philosophical. So what happens if you do something out of scope? It depends. If it's like a small thing, like if they said, we'd like you not to run a vulnerability scanner on our static page, and you do, then they're probably going to be a bit annoyed, and they might ask you to stop or refuse to give you any bug bounties in the future. But if it says it is out of scope to go and blackmail our their employees, you're going to jail. It's frankly, don't try as hard as you can to stay in scope, because the way to think about it is illegal to do hacking on someone unless they tell you you can do hacking in that specific way. So if you've done hacking which isn't in that specific way, then you've committed a crime of hacking. It really depends on how much damage you cause and stuff like that, but I try as hard as I can to stay in scope, because it also makes you harder to be employed. Who would you rather employ? Would you employ the guy who follows the rules and does what they're told, or the person who keeps being thrown out of bug bounty programs for doing dodgy stuff? Am I still buffering? Okay, can someone confirm if it's just, actually no, I'll just say, is it just question? Yeah, I'm sorry about my trash Wi-Fi. I've tried everything to fix it, but like no one understands why it's broken. It's probably Virgin Media. Okay, fine. It's just Matt. Ha! I'm not the only one with terrible internet. Get in. Um, so let's go. Yeah, I mean, I'm dropping packets like nobody's business, but it works for now. Anyway, I'll progress. So, how to mess with vulnerability scanners. So first of all, you can do like active defenses. So look for them and block them. But blocking them directly is generally not sufficient because whilst you'll stop, the really, really low level script kiddies, often they'll just find a way around it. They'll use a VPN, they'll mess with their traffic, they'll change their user agent and stuff like that. So what you can do is you can send them to a static site with no vulnerabilities. You can send them to a static site with fake vulnerabilities. You can send them to just random sites. And you can also respond slowly to slow them down. I've seen all of these things employed in various cases. They're quite useful. There's a good talk in the description about how to do these things. One of the things it goes into is a more transparent way of messing with automated vulnerability scripts. So, I'm still good. Okay, great. By transparent, I mean things that don't affect a normal user in any way, which you just present the same page and bots will handle differently. So, a classic thing is to just send 404, but actually embed the content within that 404 page. So that a script that's going through will go, oh, look, there's no site here. But a normal user won't even notice the 404. Because the actual response code is only really used for edge case caching, things like that. You can actually get a long way by just sending random response codes and just having it work. Again, I really would recommend the talk in the description. I think it's pretty much what inspired this talk. And of course, the classic thing, you can just dynamically load content with JavaScript. I have never come across a vulnerability scanner for websites that automatically runs and parses JavaScript. And if there was, it would be massively slower and effectively equivalent to just browsing the thing manually. So it's... And there are some downsides to dynamic loading things with JS, but I mean, frankly, everyone does that now. I mean, pretty much every website you come across will have like dynamic loading as you come in. It will load more and more bits to sort of smooth your experience. A big concern for me is that, so Matt's just asked, a big concern for me is that I will do something that you shouldn't because I didn't read some bit of the law, something like that. Right, okay. So, yes, that is a worry. No matter, and I mean, this isn't unique to cybersecurity. Anything which involves interacting with other people, someone might not even have the permission to give you permission to do something. So, for instance, if a classic example we hear loads and loads of times from pen testers is someone important gives you a list of IP addresses that you can spam with attacks and accidentally gives you like a military one or something like that. You need to try as hard as you can to make sure that there isn't anything confusing. Like if it looks a bit questionable, like it's owned by someone who they contract with rather than actually them, don't do it. Okay? Get confirmation from like everyone you can. But frankly, in most cases it should be pretty clear. If they've written, they'll write on their, they have a website, they will say you can do these things to our website. Only do those things to their website. If you come across other stuff, it's a bit harder to do disclosure. That's a whole different talk. In fact, we could probably do one on responsible disclosure at some point once we get that set up. But it's a judgment thing. And just generally, don't do things that are stupid. Okay? Don't DDoS websites. Don't try and exfiltrate everyone's passwords unless you're given explicit permission by them and probably the users. It's just could be dubious. Just err on the side of caution. Because frankly, as a pen tester, all you're trying to do here is find bugs that they can fix. and make money. That would be nice, but make money by finding big bugs. So as long as you can do something bad and tell them that you can do that something bad, you don't necessarily have to do something that is bad unless they say that you can and don't believe that you can, which is quite a weird corner case to be in. But yeah, I'll go into responsible disclosure at some later point, right? But generally, be cautious, do what makes sense, and don't be stupid, basically, I think is the good way to do it. Yeah, don't be illegal or dead. That sounds like a good sort of general advice for life. Thank you. Anyway, I'll go back to this. So, next slide. Metasploit. Right, I don't know if we've done a bit of Metasploit. We're probably going to do it properly at some point. No one in the committee really wants to do a proper session on Metasploit because it is very much script kiddie hacking. It works, but it's not. I don't know. I mean, some people find it fun, but it's whatever. I mean, if anyone here wants to, if people desperately want to talk on Metasploit, it's quite a simple tool. We can do it, but anyway. So Metasploit is a big list of public vulnerability scripts, so proof of concepts, things someone hacked together after reading CVEs, things like that. It's, as I said, quite easy to use. It's a simple command line interface. You can find a billion tutorials around the internet. And it's, it comes with the thing which is actually useful even at sort of high level pen testing is its reverse shells. It's not quite a C2 system, but it's pretty good. You can, download files, you can pivot. It has some questionable things like being able to look through someone's webcam and record audio on their mic. It goes without saying, the only time you should use that is you're doing a pen test. The big boss says, yes, you broke into my computers, but I don't see why that's bad. So you break into his computer with his consent and show him that you can access his webcam and screen and things like that. Like, it's like, again, obviously, don't do stupid things, don't do bad things. I don't think there's another way of putting it. So we'll cover how to use Metasploit maybe in a later talk. But it's suffice to know, it's quite a common thing. Now, pretty much everything on Metasploit is old and patched. By the time a vulnerability gets disclosed, it's usually a patch is available for it. So keep all of your software up to date. Who knew that could stop attackers, right? You'd think it would be common sense, but I know of a large organization you may have heard of who have upgraded to deprecated software rather than going for the latest version of stuff. And necessarily there's going to be exploits against it. Also, just as a general security rule, you want to go for principle of the least privilege. This is a classic mantra in cybersecurity. You should have it drilled into your skull. It's what you need to do is for any system you design, it should have the least amount of powers, the fewest things it can do while still being able to do its job properly. So, for instance, I've got here, if you've got a blog which runs on the same site as your website, which you can buy things from, your merch site, you don't want someone who can post a funny comment with some PHP in it to be able to start exfiltrating bank details. You want to keep things separate, and you want to keep them having the least amount of powers you can get away with. And okay, keeping yourself up to date is the most dangerous thing. Again, so that is a classic business decision. Do you update to something that could break, but is more secure? For servers, for Linux, that like updating and breaking things is, I'm not saying it's impossible, but for a distribution, it's entirely built around stopping that stuff happening. You've got the person who wrote the patch who needs to not notice it. You've got the people who coordinate the software who need to not notice it. You need to have the maintainers of your distribution, as they test it with, not notice it before it goes into your system. I mean, new code does bring new bugs, almost certainly, but it fixes old ones. And frankly, the idea is the new bugs won't have been found. I think that's a horrible way of thinking about it, but a bug that's been around for a decade is more likely to be used against you than one that was found yesterday. There are problems with updating software, as Matt is spamming in the chat. But if you're running a server which hosts a web server, the chance of there being a breaking update is rather low. And it's much more likely that someone's hacked into the thing and can start messing with your system. So, the classic thing to do is don't update unless it's been tested for 3 months or something, or there's been a giant security vulnerability. And in fact, that's how most Linux distributions work. That's how Debian works, which is the one which I use for servers and many people do. Anyway, now, the last way of protecting against Metasploit, because it's so widely used, especially its shells, is, and this is the only time you're going to hear me recommend this, is antivirus. Anything that is, it's a commonly used thing, it's a commonly used attack, therefore it's probably under an antivirus watch list. Let's do an antivirus rant. Antivirus only deals with well-known threats, so Metasploit reverse shells are commonly known, their signatures can be easily traced. You just have something that scans through your memory looking for the word Metasploit. It's a bit more complicated than that, but not much. Occasionally, it will catch things that are, behaviourally bad. So, novel malware being things like, you've hacked up a reverse shell. What it does is it, deletes system32. This is not a subtle action. An antivirus can probably detect it, but frankly, I expect anyone who can program to be able to bypass bypass antivirus. It takes a bit of time, but frankly, I think it's not that hard. You can actually mathematically prove that antivirus can't defend against all threats. Something called the halting problem shows that you can't. And of course, if you've got a virus that takes over your antivirus and uninstalls it, your antivirus ain't gonna be able to do anything, right? So you need to... Antivirus helps against small things, and for desktop PCs, probably, because, browser exploits are pretty common, something bad gets onto your system, you don't want it ruining your day. You've got mail worms still, you still see them. But for large servers, you probably want something more like one of those very expensive and snazzy, intrusion detection systems. And antivirus isn't going to help you too much against targeted novel attacks. So, credential spraying. Now, this is something I've actually looked at, not in doing, but in defending quite a lot. So it's quite a complex procedure. You Google most common passwords and then the name of the service. You then brute force the IPv4 address space, looking for things running that, and spam the passwords at it, and then you might get into 1 or 2 servers, maybe. This brute forcing is actually often known as the internet background noise, because it's ever present. If you run a SSH server and expose it to the internet, you will notice a vast number of requests and just general people trying to get into your server. It's quite fun to watch. It's not necessarily something you should be worried about too much, but there are things you should do to mitigate it. So first of all, fail to ban. This is a Linux package. It listens to your SSH server logs. If someone types in the wrong password a configured number of times, I think it defaults to 3, it blocks their IP address for a minute or an hour or something, which massively decreases an attacker's ability to spam you. They run out of IPs. Obviously, they can spoof IPs and things like that, but that's a lot of extra effort. All these defenses just make things a bit harder. And of course, disable SSH password login. You should not own a server with password-based SSH login. Like, I can think of one possible reason, which is you can't be bothered to syndicate a public key around people who use your server. You want them all to use a common password they can remember, and they need to access remotely without access to their desktop. But like, just don't do it. Just look it up online. It's literally changing a single line of a config file and then restarting SSH, and it will block any password-based attack because they won't be able to log in with passwords. I do this on any server I get root on, basically, because it's just not. It shouldn't really be enabled by default. Of course, you can also, for websites and for custom written services, so APIs, whatever program you're writing, distributed systems, things like that, you can have a proof of work system or a captcha that they have to fit in before the password actually gets checked. It's for those reasons it's actually better to do that before checking the password, not check the password and then verify their token. But and again, this doesn't stop them, this just slows them down. But the slower they are, the less passwords they can try, and therefore the longer it will take for them to actually get onto the correct one. For large-scale systems, or for something you care desperately about, you can set something up to look through your SSH log, and if it suddenly gets long, that probably means that you've been spammed a lot. So get it to send you an email, just so that you can check that nothing bad is happening. And I know this will come as a great shock to absolutely all of you, you shouldn't use common passwords. If it's not on a password list, it's going to be quite hard to spray against your server. Anyway, I think that's everything. Sorry for the shambolic bit rate. I'm going to head over to Discord now. So, yeah. Thank you very much for listening. And bye.